Good afternoon, everyone. Welcome to I Square Maths Academy, where numbers and variables actually meet mastery. Today, we are going to be looking at a very important topic in mathematics. Yes, indices. Yes, so we are going to be looking at indices and, of course, the laws that are guiding indices. Now, first of all, what are indices? Indices are functions that involve powers. Yes, indices are functions that involve powers. Now, let me put it here. Indices are functions that involves powers. Yes. Now, let's look at this. M raised to the power of x. Let's look at the meaning of this. M raised to the power of x. Now, the meaning of m raised to the power of x is m times m times m times m continuously in the x places. Yes, in the x places. Yes, that's the meaning of m raised to the power of x. That is, you multiply m by itself into x places. Now, this is what we're saying. If you have 2 raised to the power of 5, the meaning of this is 2 times 2 times 2 times 2 times another 2. 1, 2, 3, 4, 5. And of course, we know that 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So, of course, that is the meaning of 2 raised to the power of 5. Now, if you have 3 raised to the power of 4, the meaning of this is 3 times 3 times 3 times 3. 4 places. Now, 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. Yes, it's 81. 81. Now, let's look at this m raised to the power of x. Let's look at m raised to the power of x. Now, the meaning of this x here, x is called power. Yes, x is called power. If you don't want to call it power, you can call it index or exponent. Yes, these are the 3 names you can call x. Either you call it power, index, or exponent. Now, the m here, this m here, is called the base. Yes, the m here is called the base. So it means when you have 2 raised to the power of 5. Now, this 5 here is actually the power, and 2 here is the base. Yes, and we have seen the meaning of this. The 2 power of 5 is 2 times 2 times 2 times 2 times 2. 5 places actually give us 32. Yes, so that is m raised to the power of x. So x is the power, index, or exponent, while m is the base. So if you want to read this, you can call this m raised to the power of x, or m index x, or m exponential x. Yes, so you can call this power, index, or exponent. So now let's look at the laws that are actually guiding indices. Now let's call it the laws of indices. Laws of indices. Yes, laws of indices. Now, because we said another word for index is power or exponent, it therefore implies that the laws of indices are also known as the laws of powers or the laws of exponents. Yes, when you hear the laws of indices, laws of powers, laws of exponent, they actually mean the same thing. Now, let's look at the first law of indices. Now, the first law of indices states that m raised to the power of x times m raised to the power of y. Yes, let's look at this. M raised to the power of x times m raised to the power of y is equal to m raised to the power of x plus y. Yes, m raised to the power of x plus y. Now we call this the multiplication law. Yes, multiplication. The multiplication law of indices. Yes, that m raised to the power of x times m raised to the power of y is the same thing as m raised to the power of x plus y. Now, if you look at this law very well, you discover that the bases are equal. So it therefore means that before you apply this law, you must ensure that the bases are equal. Now, example, let's look at 2 raised to the power of 3 times 2 raised to the power of 4. Now, this is the same as saying 2 raised to the power of 3 plus 4. Now, we are applying this because the bases here are equal. Yes, the bases are equal. So here, that will give us 2 raised to the power of 7. And of course, we know that the mean of 2 power 7 is 2 times 2 times 2, 7 places. And 2 times 2 times 2, 7 places will give us 128. Yes. Now, let's look at another one. Now, 3 power 2 times 3 raised to the power of 3. Yes. Because the bases are equal and the operation here is multiplication, it means this will be 3 raised to the power of 2 plus 3. And now it gives us 3 raised to the power of 5. And 3 power 5 is 3 times 3 times 3, 5 places. And now it gives us 243. So this is the first law of indices. Yes, now let's move to the second law. Now, law number 2. We have m raised to the power of x divided by m raised to the power of y. Yes, m raised to the power of x divided by m raised to the power of y. Now, this will give us m raised to the power of x minus y. Yes, m raised to the power of x minus y. So we call this the division law. The division law of indices. Yes. Now, example. Let's do it. 8 raised to the power of 10 divided by 8 raised to the power of 8. Now, looking at this, you will discover that the bases are equal. We have 8 here as the base, 8 here as the base, and the operation is division. So we are subtracting the powers. So it means we have 8 raised to the power of 10 minus 8. And that will give us 8 power 2. And of course, we all know that 8 raised to the power of 2 is 8 times another 8. That's 8 times 8. And of course, 8 times 8 is 64. Yes. Now, let's look at another example. Let's look at 10 raised to the power of 4 divided by 10 raised to the power of 3. So here, this will give us 10 raised to the power of 4 minus 3. And that will give us 10 raised to the power of 1. And any number raised to the power of 1, of course, is that number. So 10 raised to the power of 1 is equal to 10. So this is the second law of indices. Now, let's move straight to the third law. Yes. Now, let's look at m raised to the power of x divided by m raised to the power of x. Yes, m raised to the power of x divided by m raised to the power of x. Now, look at this law. Division. We said when the bases are equal, we are subtracting the powers. When the bases are equal, you subtract the powers when the operation is division. Now, in this case, the bases are equal and the operation is division. So it means it's the same as saying m raised to the power of x minus x. Yes, m power x minus x. And this is the same as saying m raised to the power of 0. M raised to the power of 0. But we all know that this m power x divided by m power x is the same as saying m power x divided by m raised to the power of x. Yes. And we know that any number divided itself is equal to 1. 100 divided by 100 is 1. 10 divided by 10 is 1. 6 divided by 6 is 1. So it means m power x divided by m power x will give us 1. And it's the same thing as saying m raised to the power of 0. So it means what we're saying here now is that in indices, m raised to the power of 0 is equal to 1. So any number raised to the power of 0 must be equal to 1 in indices. Now, it means when you have 5 raised to the power of 0, 5 power 0 is 1. 100 raised to the power of 0 is 1. 1 billion, yes, 1 billion raised to the power of 0 is equal to 1. Except 0. Yes, except 0. Because 0 raised to the power of 0 is undefined. It's undefined. Yes, it's undefined. So except 0 raised to the power of 0, but apart from 0, in mathematics, any number raised to the power of 0 must be equal to 1. Now, that is the third law. Now, let's see law number 4. Yes, law number 4. Now, let's do it. M raised to the power of x times n raised to the power of x. Yes, m raised to the power of x times n raised to the power of x. Now, remember in the first law, we said m raised to the power of x times m raised to the power of y is equal to m raised to the power of x plus y, because we actually have the bases to be equal. But looking at this law, the bases are not equal, but the powers are equal. So it means there's a law that actually guides when the bases are not equal and the powers are equal. So now in this case, this is the same as saying we have m times n all raised to the power of x. This is the law. Yes, that actually guides this. So in this case, we call this, let's look at an example. 5 raised to the power of 2 times 2 raised to the power of 2. Now, if you look at this, the bases are not equal. The base here is 5, the base here is 2. But looking at the powers, 2, 2, the powers are equal. So because the powers are equal, you just have to multiply the bases. So here we have 5 times 2 all raised to the power of 2. And that will give us 10 power 2. And we know that 10 power 2 is 100. Yes, 10 raised to the power of 2 is 10 times 10, which is equal to 100. Now, let's look at another example. Let's look at 4 raised to the power of 2 times 3 raised to the power of 2. Yes. Now, the bases are not equal, but the powers are equal. So this is the same thing as saying you just multiply the bases. We have 4 times 3 all power 2. And that will give us 12 power 2. Of course, we all know that 12 power 2 is 12 times 12. And that will give us 144. So it therefore means that when you have indices, when you have an operation where the bases are not equal and the powers are equal and the operation is multiplication, you just have to multiply the bases and pick one of the powers. Now let's also look at another example. Let's look at 4 times 4 raised to the power of 4 raised to the power of 3 times 2 raised to the power of 3. Yes, that will give us here, we have 4 times 2 all raised to the power of 3. So that will be 8 raised to the power of 3. And of course, we know 8 power 3 is 8 times 8 times 8, 3 places. Now, this is the fourth law. Now, let's move straight to the fifth law. Now, the fifth law. Now, let's look at m raised to the power of x. Sorry, 0 divided by m raised to the power of x. Yes, let's look at this law closely. M raised to the power of 0 divided by m raised to the power of x. Now, remember we said, when you have m raised to the power of x divided by m raised to the power of y, when the bases are equal and the operation is division, you are subtracting the powers. So it means in this case, this is the same as saying m raised to the power of 0 minus x. Yes, m raised to the power of 0 minus x. And we all know that 0 minus any value is minus that value. 0 minus 10 is minus 10. 0 minus 20 is minus 20. So it means in this case, this is the same as saying m raised to the power of minus x. Yes, because 0 minus x is minus x. So it means that, let's look at this again. This is the same as saying m power 0 all over m raised to the power of x. And remember from this law here, from the third law, we said any number raised to the power of 0 is equal to 1. So it therefore means that what we have here will be 1 all over m raised to the power of x. And now we said it's the same thing as m raised to the power of minus x. So it therefore means that m raised to the power of minus x, to remove this negative value, you just have to introduce 1 as the numerator. So it becomes 1 all over m raised to the power of x. So when you introduce the numerator as 1, the negative sign will vanish. Now, example, if you have 5 raised to the power of minus 2, now to remove the negative sign, you just have to introduce 1 all over 5 raised to the power of 2. Yes, 5 power minus 2 is the same thing as 1 all over 5 power 2. So that will give us 1 all over 25. Now let's look at 6 raised to the power of minus 3. Yes, to remove this negative sign, you introduce 1 all over The moment you bring in 1 as a denominator, the negative sign will vanish from the power. So here we have 6 power 3, not minus again because you have introduced 1. So that will give us 1 all over 6 times 6 times 6. That will give us 216. So this is the fifth law. Yes, this is the fifth law. Now let's look at law number 6. That's the sixth law. Yes, the sixth law of indices. So here we have m raised to the power of x all over y. M raised to the power of x all over y. So we can call this the fractional power law, and we can call this the negative power law. Yes, the negative power law. And here we have the fractional power law. So it means in this case, this is the same as saying y root m all raised to the power of x. Now look at the x inside the radical. Or you can also call this y root m, then everything power x. Everything power x. So here what we're trying to say now, let's look at this example. Let's look at 8 raised to the power of 2 all over 3. Yes, 8 raised to the power of 2 all over 3. So in this case, you can express this as the cube root of 8 all power 2. Yes, or you can call this the cube root of 8 everything raised to the power of what? 2. Now, because the first one here, this one here, is saying the cube root of 8 times 8, and 8 times 8 is 64. Or here we have the cube root of 8 is 2, and here we have power 2. So looking at this, the cube root of 64 is a number that will multiply itself 3 times to give you 64. And that number is 4. Yes, because 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So it means the cube root of 64 is 4. Or here we have it 2 power 2 is 4. So you can use any of this. Yes, you can use either this or this. It will give you the same value. Now let's look at another example. Let's look at 27 raised to the power of 5 all over 3. Yes, 27 raised to the power of 5 all over 3. Now, this is the same as saying the cube root of 27 all raised to the power of 5. And of course, the cube root of 27 is a number that will multiply itself 3 times to give you 27. Or a number that can multiply itself 3 times to give you 27. And of course, we all know the number is 3. Because 3 times 3 times 3. 3 times 3 is 9. And 9 times 3 is 27. It means the cube root of 27 is 3. And here we have power 5. And here we all know that 3 power 5 is 3 times 3 times 3 times 3, 5 places. Yes, and that will give us 243. Now, this is the sixth law. Yeah, this is the sixth law. Now, I want to add another example here. Yes, to the sixth law. I want to add another example to that particular law. Okay, now let's look at this. Let's look at another example. Let's look at 64 raised to the power of minus 2 all over 3. Yes, 64 raised to the power of minus 2 all over 3. Now, if you look at this very question here, you'll discover that the power here is actually carrying a negative sign and also a fraction. So it means we're going to be applying 2 laws. That's the negative power law and the fractional power law. Now, remember what we said about the negative power law, that to remove the negative sign, you just have to introduce 1 as a numerator, then the negative sign will vanish from the power. So now, in this case, we'll have it as 1 all over, we have 64. Now, because we have introduced this 1, yes, as a numerator, negative sign will vanish. So we'll be left with 2 all over 3. Now, we have 1 all over, because the power is still a fraction. So we are still going to apply the sixth law. So here we have the cube root of 64 all raised to the power of 2. So it therefore means that 64 raised to the power of minus 2 all over 3 is the same as saying 1 all over. The cube root of 64 is a number that will multiply itself 3 times to give us 64. And the number is 4. So here we have 4 raised to the power of 2. Yes, 4 power 2. So that will give us 1 all over. 4 power 2 is 4 times 4. And that will give us 16. So the answer to this question, the value here is 1 all over 16. Now let's move straight to the seventh law. Yes, let's move straight to the seventh law. Now, for the seventh law, before we move straight to the seventh law, let's also look at this. Let's begin. 64 raised to the power of 1 all over 2. Yes, 64 raised to the power of 1 over 2. Now, ordinarily, if we are going by that law, it means this, we'll just call it 2 root 64 all raised to the power of 1. Yes, but now let me state this. Because the value here is 2. So putting 2 here is tautology, is repetition. Just like when you have a value like this, the square root of 4 is a number that will multiply itself 2 times to give you 4, which is 2. So putting 2 here, that's the 2 root 4 is repetition. So there is no point putting 2 there. So you can just leave it as the square root of 64 all power 1, which will give us 8 power 1, and that is 8. So it therefore means that when you have m raised to the power of 1 all over 2, yes, when the power is 1 over 2, the denominator is 2 here. That's the denominator of the fraction is 2. It will just give us the square root of m all raised to the power of 1. So that is the sixth law. Now let's move straight to the other law. That's the seventh law. Yes, the seventh law. Now the seventh law is the double power law. Yes, the double power law. Now let's look at it. Double power law. Yes. Now number 7. Let's look at m raised to the power of x, then raised to the power of y. Yes, m raised to the power of x raised to the power of y. Now you can see here that there's a power here inside the bracket x, and there's another power outside y. So when you have double powers, it means you just call it m raised to the power of x times y. Yes, which is m raised to the power of x, y. Yes, you multiply the powers. So it means if you have 2 raised to the power of 4, all raised to the power of 2, there's the same as 2 raised to the power of 4 times 2. And that will give us 2 raised to the power of 4 times 2 is 8. And 2 power 8 is 2 times 2 times 2, 8 places. And that will give us 256. Yes, that will give us 256. Now let's figure 10 raised to the power of 10 raised to the power of 2, then raised to the power of 3. That will give us 10 raised to the power of 2 times 3. Yes, so that will be 10 raised to the power of 6, and 10 power 6 is 1 million. Yes, that's 10 times 10 times 10, 6 places. Now let's figure this again. 5 power 2, all power 2. That will give us 5 power 2 times 2, and that will be 5 raised to the power of 4, which is 5 times 5 times 5, 4 places, and that will give us 625. Yes. Now looking at this now, like let's look at this now. Let's look at this. Now, this 5 power 2, all power 2, remember it's the same 5 power 2 times another 5 power 2, because this is the square. Yes, square of this. So now from the first law of indices, we can also say this is the same as 5 raised to the power of 2 plus 2. And that will give you 5 raised to the power of 4, which is 625. Like this same value here, the same value with this. So that is the seventh law. Now let me state this. Now remember in physics, we have Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. And it is generally accepted that if they ask you to state the first law of motion, you must state the first law of motion. If you're asked to state the third law, you must state the third law. But in this case, for indices, there is no specific law here. Yes, that there's no specific law that must actually come as law number 1, law number 2, or law number 3. So here we are actually using this. Now, in this, what I'm trying to say is this. I can decide to bring this law as the first law. I can decide to call this the second law. I can decide to call this the third law. So all these are the laws of indices. Now we're going to solve one question. Yes, we're going to solve one question under this law. Yes, one full question under the laws of indices to actually summarize all what we have done under the laws of indices. Now let's call it example 1. Now example 1. Now evaluate 27 raised to the power of minus 2 all over 3 times 64 raised to the power of 1 all over 3 times 1 all over 28 raised to the power of minus 2 all over 7 times 32 raised to the power of 1 over 5 times 89 raised to the power of 0. Yes, now we can see that all these values here, they all have powers. Yes, so we are going to be solving this, applying all the laws of indices that we have covered so far. Now, let's look at this. Solution. Now, if you observe, this 27 here is carrying a negative sign. So the first thing is to remove this negative power. So here we have 1 all over 27 raised to the power of 2 over 3. Now remember we said from this law, the law that actually guides negative power, that's the negative power law, that to remove the negative sign, you just have to introduce 1 as a numerator, and the negative sign will actually vanish from the power. Okay, so here, let's look at this. This 64 has no negative power. So this is the same as saying 64 raised to the power of 1 all over 3 divided by 1. Because we all know that any number divided by 1 is that number. So here we have times, there is another function with the negative power. So we have 1 all over 128 power 2 over 7. Then we have times 32 power 1 over 5 divided by 1. Then here we have times 89 power 0 divided by 1. Now we have arranged this. Now, this 27 is carrying a fraction. Yes, the power is a fraction. So here we have 1 all over. To express this, we have the cube root of 27 all raised to the power of 2 times. Now 67 is also carrying a fractional power. So here we have the cube root of 64 raised to the power of 1 all over 1 times. Here we have 1 all over. This will be the 7th root of 128 raised to the power of 2 times. Here we have the 5th root of 32 raised to the power of 1 all over 1 times. Remember we said any number raised to the power of 0 is 1. So here we have 1 all over 1. Yes, we have 1 all over 1 because 89 raised to the power of 0 is equal to 1. Any number raised to the power of 0 must be equal to 1 except 0. 0 raised to the power of 0 is undefined. Now, in this case, we have 1 all over the cube root of 27 is a number that will multiply itself 3 times to give you 27. And of course, we know that it's 3. Yes, because 3 times 3 times 3 will give you 27. So it means the cube root of 27 is 3. So here we have 3. Remember, there's a power there. We have power 2 times. Now, let's look at cube root of 64. Cube root of 64 is a number that will multiply itself 3 times to give you 64. And the number is 4. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So the cube root of 64 is 4. So we have 4 raised to the power of 1 all over 1. Then times 1 all over. The 7th root of 128 is a number that will multiply itself 7 times to give you 128. 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. So it means here we have 2, the 7th root of 128. Then here we have power 2. Then times the 5th root of 32 is a number that will multiply itself 5 times to give you 32. And the number is also 2. Yes, let's look at it. Yes, let's look at it. 1, 2, 3, 4, 5. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So it means here the 5th root of 32 is 2. Power 1 all over 1. Then here we have times 1 over 1. Now, in this case, what we have now will be the value now we'll have now will be equal to, now let's do it here, we have 1. So we have 1 times 4 raised to the power of 1 is 4 times 1, yes, times 2 raised to the power of 1 is 2 times 1 all over 3 power 2. That's 3 times 3. Then here we have times 1 times 2 power 2 is 2 times 2 Then here we have times 1 times 1. Now the whole of this now will be equal to 1 times 4 is 4. 4 times 1 is 4. 4 times 2 is 8. 8 times 1. That will give us 8. All over, here we have 3 times 3 is 9. 9 times 2 is 18. 18 times 1, 18. 18 times 2 is 36. 36 times 1 is 36. Times another one, that will be 36. Now, I take it again. 1 times 4 is 4. 4 times 1 is 4. 4 times 2 is 8. 8 times 1 is 8. 3 times 3 is 9. 9 times 1 is 9. 9 times 2 is 18. 18 times 2 is 36. 36 times 1 is 36. 36 times 1 is 36. So here, let's look at this now. 4 here is 2, and 4 here is 9. So it means the final answer is 2 all over 9. Yes. So it therefore means that the whole of this, 27 raised to the power of minus 2 all over 3 times 64 raised to the power of 1 all over 3 times 128 raised to the power of minus 2 all over 7 times 32 raised to the power of 1 over 5 times 89 raised to the power of 0. The answer to this is 2 all over 9. So thank you so much for watching. Yes, in our next section, we're going to be looking at logarithm. Yes, the logarithm of a number to a given base. Please subscribe, watch, and share with your friends. Thank you, and God bless you.